Hi guys and welcome to another video. So in this video we're gonna talk about a record that was broken on training the ImageNet and LXNet networks. Okay, these are classification datasets. They are that is a kind of a benchmark to see how good or how fast you can train deep neural network models. So this SenseTime trains a ImageNet or LXNet in 1.5 minutes. Yeah, that's true. So let's just take a look at how it does this. So I'm gonna read the article just a little bit. You guys can check the full article on Medium. Okay, so researchers from Beijing-based AI unicorn SenseTime and Nanyang Technological University have trained ImageNet in a record-breaking 1.5 minutes, a significant 2.6 times speed up over the previous record of 4 minutes. Since 2010, the ImageNet large-scale visual recognition challenge has been an essential benchmark for examining and testing image recognition algorithms. So you guys can see the last record was 4 minutes, and now the new record is 1.5 minutes. That's a huge improvement, 2.6 times. So the thing is, let's just take a look at some of the architecture of this specific model. So the LXNet and ResNet 50 networks, along with the ImageNet datasets, are well developed and useful for image recognition tasks. Although various image recognition studies and methods have been achieved to high accuracy on ImageNet, the training process remains time-consuming. For example, a single NVIDIA M4 GPU requires 14 days to complete 90-epoch ResNet 50 training. Shortening these training times has emerged as a popular and practical challenge for AI researchers. So you guys can see that nowadays these datasets they are like well defined, they are popular, so researchers are not trying to get this train these models in as fast as possible. So the SenseTime and Nanyang team use a communication backend called gradient flow and a set of network optimization techniques to reduce the deep neural network model training time. The researchers also proposed lazy hour reduce to fuse multiple communication operations into a single one. They discovered that popular open source DNN systems could only achieve 2.5 speed up rate on 64 GPUs connected by a 56 gigabit per second network. So yeah, so you guys can see that they use a lot of GPUs. Researchers use 412 GPUs Volta. So you guys can see that this cannot be achieved by someone. It needs to be a huge research team. So this costs a fortune. So they achieved 58.2% accuracy in 1.5 minutes, which corresponds to training throughput of, you guys can see, they are passing almost 1 million images per second. So it's 1,514.3 thousand images. Okay, so they are passing 1.5 million images per second, but they put a K here. So yeah, and for 410.2 speed up ratio. The previous record that was had by Tencent Machine Learning. Okay, so there's some details there. You guys can see that there are some of the details of the implementation. Okay, so that's it, guys. You guys can see that this is a full article. I'm gonna link the article in the description down below, but I'm just gonna add a simple comment here. So you guys can see that they achieved this because they were passing large batch sizes. So if you kind of want to see if you can train your model faster, the one thing that you should look for is to pass larger batch sizes. Okay, so this is one way you can achieve this. Although this is training on a peer-to-peer environment or machine, because they are using multiple GPUs in multiple devices, so they kind of have to come up with a solution to update the weights. That was the overreduce function. I think if they release a open source solution to incorporate, let's say with TensorFlow or PyTorch, that would be very cool, because they pretty much had a good solution and they could break this record. So thank you guys for watching this video. See you guys next time.